seeing if that is a little bit brighter. Okay. So last lesson for today, we're going to start with our first formula, our first calculation. So we are looking at, let me see here, how high can I go here with you seeing? Okay. We are looking at magnification. So there is a note that you guys have that you can fill out. I do not have a copy of that note in front of me. So I take a picture of the unfilled out one, and I don't have any of the handouts for that. So I'm just going by the unfilled out one to fill it in, okay? So mirrors can be used to change the size of an object's image, right? So we already established that with the ray diagram. So the concave mirror was able to increase the size of the image when it was behind the focal point. And on the reverse side, the convex mirror shrank the image, right? That was the one that was security that can be used in like convenience stores, right? It takes it shrinks the objects to give a wider field of view so they can get more into that mirror, right? You can have more images put into that mirror of everything around you. Okay, so magnification. So in that part there where it's magnification definition, you can write in the measure. I'm trying really hard to be neat. I know it doesn't look. I'm looking at the screen and it's not neat at all. The measure of how, I'm going to go slow so that it looks neater, of how much larger or smaller. Can you see that still? Move that over a little bit there. Okay. Or smaller. An image is compared to the object itself. Okay. So the magnification of an image can be the same size as the object, smaller than the object, or larger than the object. So we did see that. So when the object was at the center of curvature for the concave mirror, remember the image, it should have been right underneath it, but is the same size. Okay. And then as you move that object closer towards that concave mirror, the image went further away and it got bigger. And then when we had the object in front of the convex mirror, the image got smaller. Okay, so all different size images. There are two equations that can be used to calculate the magnification of an image. So the two magnification formulas, okay, is going to be, first is, I'll put it over here. Magnification equals high over ho. Hi ho. Hi ho. It's off to work. We go. You got that? Yeah. So what is this? Image height. Object height. So all it's doing is comparing the height of the object to the height of the image, right? So it's just contrasting the two of them, or comparing. So that is one. Now the other one is same thing. We're going to end up using these together as well. Magnification is di over dou, but this is where this one gets tricky. Okay, di over dou, but there's a negative in front of this one. Okay, and it doesn't make sense right now why there's a negative in front of it. The textbook actually doesn't teach the simple versions with a negative, which is kind of irritating, because then afterwards we use these together, and then you have to reteach. Then it shows you with the negative, and kids are like, why is this all of a sudden there's a negative here and it wasn't before? So just go with this. You get your formulas on your test anyways, and you will have to do the math questions for your unit test or quizzes, but you get the formulas. I will give you the formula with a negative there, okay? And I'll explain where the negatives come into play here. So this is your image distance and your object distance. Sorry, I was neat and then I got carried away. So again, when you make sure when you're using both of these equations that you use the same units. So always pay attention to the units. Sometimes one will be in centimeters, the other will be in meter, and you'll have to convert them. And same as the heights, the distances, that they're all in the same units. Okay, so if the image is bigger than the object, then magnification will be bigger than 1. Okay? Oh, sorry. So, so image is bigger, right? Magnification will equal 1 if image is same size. Well, there's no images, sorry. Same size of the object. Magnification will be less than 1 if image is smaller than the object. Okay, we got that? Okay, so that's all that you need to know for this. And we're going to do that practice question. Where is I took a picture of your practice question to go over it. Okay, so we're going to do the practice question. Actually, I'm just going to explain. I'm trying to decide here. I'm going to explain why there's a negative there. It's there in this equation because it has to balance some of them out. Because when you get a negative, let's do like the concave mirror. This is kind of where the math comes in. You kind of want to think of it like a quadrant. Okay, so if the object is here, okay, and then you have a virtual image and the distance is over here, your image distance is going to be a negative, right? Or if the height of your object is here, this is the height of the object, and it's going to be positive in this quadrant. The height of the object is positive here, but all of a sudden you get an inverted image down here, that's going to be a negative. So we're almost breaking it up like that math, right? Positives, negatives, all right? But in this case, if it's a concave mirror, the side of the mirror is positive, so positive, negative, okay? As long as you remember that your di over dou is negative, you're good. But also remember that sometimes you're going to get answers that have a negative, and that's right, okay? So depending on where the distance is, where the distance is or where the height is, if it's inverted or not, you could end up with a negative. So di, hang on. So I'm just write this here and maybe write this down. Oh crap, if you can see it. Oh, I should care about this. So di, so distance of image is negative for virtual images. Okay, so these are things that you need to put in when you're doing your equation. Okay, which means, and you'll practice this a lot, and we'll take a bunch of them up tomorrow because I'm assigning a bunch today. But if it's a virtual image, then you have to put the number in as a negative. So even if we had then m equals negative di over dou, and in the equation it says the image, the convex mirror created a virtual image that is 10 centimeters. It's telling you that it's a virtual image, so then you will therefore have to go in and put it in as a negative as well. Okay? over dou. So it's going to end up crossing each other out, and it's going to end up being a positive, which is right because it's going to end up being, you know, a big, actually in this case, it's going to be smaller magnification because it's a convex mirror. But even still, it's still going to be a positive magnification, okay? So you always write the equation like so, m equals negative di over dou. But something that you need to remember is that if it's di, and it says in the written thing that it's a virtual image, you have to include it as a negative. And then the other one is, no, the other ones are for lenses, which we haven't done yet. I'm just trying to make sure that I've given you all of the tidbits for this one. So that's it. So for this one, you're only having to remember that if it's a virtual image, you have to put it in as a negative as well. Okay. All right. So let's do the practice question. Let me just pull it up because I took a picture of it so I could do it with you guys. All right. So a candle is placed. Okay. So this is where you need to set everything up, as we haven't gone over any of the math yet. It's only day 3. So carry your good habits from math class, is that's what I want to say. Okay. So, some teachers will give you, like, I guess Gus is one of the things that they use as, which is start with your givens, right? So I'm going to write it out. I'm just going to practice math right now because I'm a good student. No. Okay. So reading the question. A candle is placed 22 centimeters from a concave mirror. A virtual image is produced, what does that say? 53 centimeters from the mirror. What is the magnification? So what are our givens? A candle is placed 22 centimeters from a concave mirror. Okay, so a candle is placed 22 centimeters from a concave mirror, which means the candle, even though it's the light source, it's also the object. Okay, so distance of object, okay, is 22 centimeters. A virtual image is produced 53 centimeters from the mirror. Distance of image is 53 centimeters. Okay. We've got di and we got dou. We also have a virtual image. So it's telling us it's virtual, which means you need to put in the negative here. Okay. So because it's virtual, we know it's behind the mirror, and that gives us that negative. Okay, so now let's start with, we've gotten our givens. All right, our unknown is our magnification. So we know that. Okay, sorry, I can't really see that. Now, first thing you do, we're starting with our equation. So always write the equation out first. Oh, that doesn't look like it did at all. So this way I can see, because I try to give part marks wherever I can. So I want to make sure that you've written in the equation properly before you filled it in. Okay, I want to make sure you're using the right equation. So you start with the equation first. Have it blank, not filled in at all. Now we're going to fill it in. Okay, we're going to have our negative, but we're going to have another negative. And it's over di over, and it's over 22. Okay, so we've got our di over dou. If you want, you can just do it now. Take away the negatives. And what is our answer? It's going to be around 2 point something, right? 2.4. Magnification is 2.4. Oh, sorry, guys. I didn't even show it to you. There we go. It's not coming up very clear anymore. There it is. Sorry. Okay. So magnification is 2.4. Few things to remember. Magnification does not have units with it. So if your right answer here, magnification is 2.4 times, right? You can write times beside it. Or you can just say magnification is 2.4. You don't even have to write times. There is no units. Okay, so that's just the number. So usually you'd write your therefore statement, okay? And you'd say sentence as in, magnification for this virtual image would be 2.4. And that's it. I have included a sheet for you guys to practice your magnification questions. So I would like you to work through those. One thing we didn't really get to work on in class, because we're not in class, is isolating for a variable, okay? And I find that the grade 10s in every class I've had, it always seems about 50% of the class can't do it, okay? And that kind of baffles me. But let's look at, I'll do the high over whole one just because then we don't have to worry about the negative right now. So if magnification equals high over whole, okay? And we are given the magnification and we are given the high. And we need to find out what whole is, okay? You have to isolate for this variable. And kids seem to struggle with that. And even though like you've done this before in your electricity unit with Ohm's law, you have it, it's the same thing. And you know, some teachers show you the whole pyramid method. Math teachers don't like that. They want you to have the skill of being able to rearrange that equation, okay? So it is a skill. It's not an easy one. So one thing you have to remember when you're isolating for a different variable in the equation is always tell yourself opposite operation, okay? So in this case, this is a division. We want to get whole by itself. So we want to get it over here, okay? So to get it over here, it's being divided out right now. Well, to get rid of it on this side, you need to multiply it, okay? That's how we get rid of the whole. We multiply by whole. So when you multiply by whole, that takes this one away and this one away. But whatever you do to one side, you have to do to the other. So then it becomes magnification times whole equals high. Oops, sorry, I should put that. That's not nice. Over here. Magnification times whole equals high. Okay? It's the opposite operation. So now we still need to get whole by itself, and it's multiplied by magnification. Well, it's multiplying. How do we get rid of magnification? We need to now divide it out. Okay? And when you have it on top and you have it on bottom, you can get rid of them both. But whatever you do to one side, you have to do to the other. Okay? So now all of a sudden we have whole isolated. And it's going to be whole equals high over m, which is magnification. Okay? Practice that a couple times, all right? Practice doing this, and then practice rearranging the same equation for high. Okay? And if you struggle, pop onto the Google Meet, and maybe we can just go over a couple of them together, okay? But this is an important skill, and I'm telling you right now, this is an easy equation to use right now to try to practice isolating. We're going to get into a couple more very complicated ones, and you're going to have to be able to isolate for everything in those formulas. So practice with this one. Know how to isolate for different formulas. And always remember, just opposite operation. If it's being divided out, multiply it on that side and that side, right? Whatever you do to one side, you have to do to the other. And if it's being multiplied, divide it out. But whatever you do to one side, you have to do to the other. So practice that a couple times, just isolating for the different variables here. Okay? And then now go and try to practice your magnification questions. And then if you have any questions, pop onto the Google Meet, and we can take up a couple of them on Thursday morning. Okay? And that's it. That's it for today.